Right, table shows information about weights of eggs. Calculate a mean weight of the egg. So we've got the midpoints. Just going to take a guess here, between 0 and 30, so it's the middle values. A good guess to take. Then we've got fx, which is the frequency times the midpoint. So when we've done that, we'll then add our fx up. And we've also then got add this up, which is the frequency. So this is the total weight. If you put all the eggs on the same scale, then it would equal that many grams. So it's the total grams divided by the number of eggs, which then gives you 59.5 grams. So that's then your the average weight there. Then we're going to complete the cumulative frequency table. So cumulative frequency is think of it as a snowball rolling down a hill. It accumulates snow as it's going, so it starts from 0 to 30. How far it's rolled down, it's not picked anything up. But then when it rolls from 30 to 50, it picks up 14 bits of data. Then from there to 60, it picks up another 16 bits on top, so that's 30. Then add 21 on, you get 51, and then add your final 9, which gives you 60. We then plot these on the graph below. Now in drawing them, you've got to take your top value because you need to roll through all up to 30 and there's nothing there, but from 30 to 50 you've got to get to all of the 50 to get all the 14 grams of snow, if you want to think of it like that. It's a snowball. So first value is 0. We've then got 50, 14. We've then got 60, 30. We've then got 70, 51. And then we've got 100, 60. There's quite a curve there at the end. So I'm going to do my best on here. This may be laughable, but we'll do what we can. The curve at the end may be slightly more smooth, but you've got the general idea. And they usually graph to find an estimate for the number of eggs with a weight of greater than 63 grams. So 63 grams here, we then go up to it, and where we hit then we go across. And that will then give us, going upwards, 1, 2, 3, 4, 5, 6. So 36 then, that's C done there. That's B. That's A. And then D, we're going for 36. Accepted region there. They're actually just looking at it and saying if you've drawn it and you found your value. Now interestingly, I'm just having a look at this and I've just realised it says estimate the number of greater than. So I've fallen for it, haven't I? Because I've said less than. There's 36 eggs less than that. It's these ones above that we're wanting. So it's 60 then. Take off 36. Things just 24. So yeah, it's 24 eggs then above. Long-winded question. Question 11. Probability is a tree diagram. We've got probability Martin will bring a calculator and the probability Luke will bring. So Martin bringing his 0.8, so he won't bring his 0.2. Luke bringing 0.6, he won't bring his 0.4. 0.6, 0.4. Work out the probability that both Martin and Luke will not bring. So it's not and not. So this is for B. Probability of not and not is 0.2 times 0.4. So then gives you 0.08. Question 12. 182 students in total there. Activity there, they've picked climbing or sailing, and males and females. Wants to take a sample of 50. The number of male students who chose climbing should be in the sample. So it's 34 out of 182 times by your sample size, which is 50. So 34 divided by 182 times by 50, and that gives you 9.3, etc., which rounds then to 9. Question 13. Toughie, this one. Some students did it manually. When I talk about manually, I talk about adding 3% on at the end of a year, then working that out, and then another 3% on. There's a general equation to work these things out. You take your original value, you times it by what we call the decimal multiplier for the percentage, so that's 1.03, because you want 100%, which is your value, plus 3% on top. And then it's the number of years. Now this time is n. After n years, an ammeter has made that much savings. Work out the value of n. So we'll just try a value. So we'll try 3 in there and see what 3 gives us. So that gives us £2,731. So it's not that, so we'll try maybe 4. See what 4 gives us. So that's £2,813.77. And you check the question, and that's correct. So then n equals 4. Again, you can do it manually, but I just prefer that way. We've got question 14 here. Use the information in the histogram to complete the table, and then we've got to use the information from the table to complete the histogram. So first thing to be aware of is this here isn't drawn, this here isn't drawn, but this one is. So what we can actually do here is put our class width in and our frequency density. The class width here is 10, so 20 divided by 10 gives us 2. So the frequency density here we know must be 2. So each 2 squares counts as 1. And that will then help us work out the other ones. Because now what we can put in is the frequency densities for these. So from 0 to 10 is 0.5. And then from 25 to 30 is 3. So our class width we know, that's 10 and that's 5. And instead of dividing to work backwards with times, that will give you 15 there, and that will then give you 5. And then to work out the frequency densities, to draw these on, we've then got the class widths here, which is from 10 to 25, which is 15. 30 divided by 15 is 2, and 30 to 50 is 20, so 50 divided by 20 is 2.5. So we've then got 15 over 15, 10 to 25 is 2. So drawing on here, we've got up to 2 there, and across. And then we've also got the other one, which is 25 to 30 is drawn. 30 to 50 is 2.5. So 2.5 then will be drawn there.